This is Martin Carlisle with Cake from pico2018 2018. Now that you're a professional heap baker, can you pwn this for us? It should be a piece of cake. Connect on port 42542. Okay, so I'm going to open up Tmux. That's basically a fancy way of doing terminals on the shell, and that's going to be important later when I'm doing JDB and pwn tools. And now I'll go ahead and connect 42542. So you can see that nice picture of a cake. I have the ability to make a cake, wait for customers, serve a customer, inspect a cake, or close the shop. So if I make a cake, I can give it a name, I can give it a price, and now I have a customer waiting, so I can serve the customer. I can give them cake 0, and now I've sold $34 worth of merchandise. I have one customer waiting. So the interesting thing here is it let me serve the cake that I had already served to a customer, so giving new meaning to the you can have your cake and eat it too. But what ended up happening here is I got a double free error where I tried to free the same cake twice. So that's going to be an important bug that's going to be exploited in our program. All right, so I have a long exploit script here. I will walk you through. The first thing to note is that I've created these routines that will interact with the program for the various things in terms of inspecting a cake, serving a cake, or making a cake. And so I can make a cake, I pass a name and a price to this method. It will do those things interacting with the program. Serve a cake, I can pass it a number, and then inspect a cake, I can pass it a number. I've also looked at this program and I've put in some offsets, and I've used the tool from the NSA Ghidra. And so in Ghidra, I've gone through and I've done some analysis of this program. Here is the make method. A couple things of note that I did. I created this data type for store after doing some analysis of the program, and I see that it has 3 fields. There's the sales, the number of customers waiting, and then an array of up to 16 cakes. And so, for example, you see that here. If the counter goes up to 16, they run out of space for cakes in the array. Okay, so given that, we'll go back to this here. I also have a bin sh gadget offset. So I've examined libc and I've found a place inside of libc that does a system with bin sh. But one of the things that's going to be interesting about this particular program is that libc is loaded at a random address each time the program is run. So I'm going to have to figure out what that address is. Okay, so one of the things that's important is that you'll saw when I tried to free the same cake twice, I got that double free error. There's a check inside of the malloc and free routines to see if you try to free the same thing twice in a row. So to exploit this, I'm going to make 2 cakes, and then I'm going to free cake number 1 twice, not in a row, freeing cake 0 in the middle. Now, I'm also setting the price of cake 0 to 33, and the reason for that is because I want to have a malloc allocation size for the block, which corresponds to 32 bytes plus the in-use bit. And so I'll show you something. In a fastbin chunk, and we can look at fastbin attacks, you can Google that and find some more information about this. If you malloc 16 bytes, what you actually get are 32 bytes, 16 bytes of header information followed by 16 bytes of data. And so we'll have the previous size as the first 8 bytes, the size and the flags, and since this is 32, and I want the previous in use bit. That's why I wanted to get this to be 33. And then the user memory, which will be the price and the name. And so if I look at a cake, which I did some analysis on, a cake consists of 8 bytes for price and then 8 bytes of characters for the name. Continuing on in what we're doing here in the script, once we have freed that cake twice, we can examine the cake and we're going to be able to find a heap value from that. And I've created some demos along the way that basically run portions of this on a file locally and use GDB. So in my first cake demo, I come down here, I'm doing the same thing. You'll note that I'm attaching to a process. I've got a copy of this executable in my local directory, and then I'm going to attach to it in GDB so I can do some things with that. Now in my GDB, I've gotten this nice pwn GDB from GitHub at this location, and I'm using that with GDB peta. And the nice thing about that is it's going to enable me in GDB to display some information easily about the heap. Here is a nice article that describes the fastbin attack. So fastbin in malloc, there are some small linked lists where it keeps track of previously allocated blocks so it can serve those up to future mallocs after they've been freed. And the key thing here is this picture, which I showed you before. When it's freed, we have the size of the previous chunk, the size of the chunk in the flags, and then a forward pointer to the next chunk in the list. Okay, so I'm going to go ahead and run. So what it's done now is it's made those cakes, it's done those frees, it's told me where the heap address is. The reason it can do that is I have managed to get my heap to have the same item in the free list twice. So I've got that item in the free list twice, which means that when it deallocates this one, it puts a pointer to a next heap chunk in the location where we would normally expect to see the price of the cake. So that username, so in an allocated, there's a price and a name here, but when it's deallocated, we have a pointer to the next chunk. So by inspecting a cake in the price field, we'll see a heap pointer that has been leaked by the fact that we've malloced and used this memory twice. Right, so you can see here, this is the malloced chunk. There's the previous block. Here's that 33 I was referring to. Here's the pointer to the next. And this is actually the name of that cake. And so you can do that. CAKE1 is what I put in there. And so those bytes are backwards because this is in little endian order. Okay, so that's enabled me to leak a little bit of information about the heap. So moving on to the second demo, what I'm going to now do is I'm going to make a cake with another name, and I'm going to give it a price that is the address of the shop variable -8. So looking here at Ghidra, there is a shop variable that keeps track of the pointers to the cakes. I've done some analysis on that. So there's the sales, which is an integer, 8 bytes, the customers waiting, 8 bytes, and then there's 16 pointers to cakes. And so that's what the shop looks like. And so I'm going to create a fake chunk that is 8 bytes before that. And so with 8 bytes before that, I'm going to be able to get information on the sales and customers and get that to point in a different way. Okay. So in Cake Demo 2, what I've done here is I've now gotten that pointer to shop -8 on the stack. And the shop is at 6030E0. And you can see that there are my $33 of profit that I've made off those cakes. And that's important because that looks like a malloc item, a malloc size. I have 2 customers waiting in line. Here is a pointer to the first cake. Here's a pointer to the second cake, etc. All right, so now I have that free list, which I have cake 1 in the free list twice. Once I've allocated this cake, because cake 1 was in the free list twice, I've managed to get shop -8 into the free list. I then will create a cake to remove cake 0, create a cake to remove cake 1. I now have the shop -8 at the top of the free list. So now when I pull this cake out, I am going to be able to get a pointer to printf into the position in cakes 0. So I'll run demo 3. You'll see that the cake array now has been modified so that I have a pointer to the printf got in the cake. And so then when I inspect that cake, I'm going to be able to find out the address of libc. All right, so everybody has been taken out of the heap that I'd freed, and I have that 2 there, which was the number of customers waiting. Let's take a look at the shop. And you'll see now that this address is where we have a pointer to the got for printf now as cakes 0. So when I inspected cake 0, I got the price of that cake, so the first location, and that turns out to be the address of printf. I subtracted the offset of printf, which I found by analyzing libc, and then I printed out here in my Python the base address for libc, and that's going to be important because I'm going to find the place where binsh is called inside of libc and make printf point to that. Okay, so once I have gotten the address of libc, I'm going to basically do the same thing again. I'll serve a cake, serve a different cake, reserve this cake. So now I have cake 1, again 3, and cake 1 in the free list. I then create a cake whose price is shop -8. Now my free list is going to have again 3, cake 1, shop -8, but it's going to have shop -8 again because of the fact that we had filled in that shop -8 up above. So if we're going to look at the free list in demo 4, we'll have again 3, cake 1, shop -8, shop -8. So you'll see it actually got a slight off by 1. One of the things that's interesting about this program is there's a little non-determinism in how many customers you have waiting at various time periods. It'll decide to add a customer to the line or not. But we've managed to get now 2 copies of this in the free list, and that's going to be important. So now that we've gotten 2 copies in the free list, the first thing we're going to do is take that first copy and send nulls, zeros, as both the name and the price. And what will be important about that is I'm going to be able to free up that 0th entry in the cake array and make it null again. And once I make it null again, I'm going to be able to put a cake back in that location. And that location, shop -8, enables me to make changes to the cake that was there, as we've seen. And then I will make another cake, and I'll tell you in a moment why this cake is particularly interesting. But let's go ahead and do demo 6, and you'll see that I'm managing to null out that place in the cakes array. And there you'll see the issue with a little bit of randomness holding me back. But I need to get just slightly lucky. So I have one more copy of shop -8 in the free list. Here you'll see that I've managed to null out cake 0. That's really important because then the next cake is going to get filled in here. And what's particularly interesting about this make is that we will be able to push something to that location of cake 0, and then once we've read the name to it, we're going to have changed that value so that we can then write again with the price. So first the name and then the price will allow us to change where printf points to point to bin.sh. So here I'm going to change where the printf points. I've gotten the libc base by inspecting that cake up here. I found a bin.sh gadget inside of libc, and when I run the whole program, it will then do another printf, call bin.sh, and away we'll go. So there's my flag, have your cake and still eat it too, or I'd sell it too. So I'll just go through this again. I've defined these subroutines so it'll make it just easier for me to make cakes with names and prices, serve cake, a particular cake number, inspect a cake number. I didn't end up using this wait routine, but that'll sort of simplify what the program looks like down below. This again using Pwn tools. I've identified where the shop variable is in memory using Ghidra. I've identified where the got entry is for printf, and the offset of printf from the start of libc. I've identified a place in libc where bin.sh is called, so there's basically a call to system bin.sh inside of libc this far from the beginning of libc. I have built 2 cakes and then use that to do a double free. With that double free, I'm able to leak a heap address. I don't end up using that heap address, but with the timing of customers in line, I wasn't able to delete this inspect. That was important in getting the number of customers in line correct so that later on I didn't end up with an invalid allocation from the heap. So I came down here, I did this shop -8, so now I'm going to be able to modify the list of cakes. I use that to make shop -8 be a freed item, and I make a cake at that location, which enables me to change the cakes array. So the very first entry, the 0th entry of the caked array, is printf. When I inspect that and get its price, I see the base for libc. I repeat the process again. I managed to get shop -8 twice in the free list. The first time I null out cake 0. The second time I managed to get that God entry in there, and then by setting the price, I changed the value of the God entry to be a pointer to bin sh. Then the next time it does printf, I'm in a shell, and I can go ahead and print the flag.